The sky at twilight feels like a held breath. You lie still, your body softened by the darkening hour, and somewhere between the quiet throb of your heartbeat and the hush of nightfall, your thoughts begin to drift. Outward, upward, inward. The stars haven't appeared yet, but already your mind senses their shimmer. Like distant bells you can't quite hear, only feel. Out there, among the stars, is a story not often told. One not written in the ordinary fabric of things, but in their reflections, their quiet in verses. You've heard of matter. You were made of it. Everything you know, every cup of tea, every sunbeam, every cell and stone is built from it. Electrons, protons, neutrons, tiny building blocks of the familiar. But this chapter begins not with the known, but its shadow. There is a twin to matter. Not evil, not dangerous in intent, just different. A perfect mirror. Antimatter. It's not science fiction. It's not magic. It's real, and it is quiet, rare, and waiting. Close your eyes and picture a world where the rules are reversed. Where instead of a negative charge, you find positive. Where particles spin the other way yet behave almost the same. Like a glove turned inside out, the shape remains, but the feel is changed. That is how antimatter exists, as a gentle inversion, a cosmic balance to everything you've ever touched. The universe, it seems, was born not of one kind of thing, but of two. Matter and antimatter, coiled together like dancers, emerging from the same mysterious beginning, the Big Bang. At first, there may have been equal amounts, paired perfectly like socks folded in a drawer. But something strange happened. For reasons not yet fully known, matter took over. It lingered. It gathered itself into stars, into planets, into you. While antimatter vanished. Or mostly did. As if it were erased softly, almost politely, from the canvas of the cosmos. Still, it left clues behind. Little echoes. And if you look closely enough, with the right eyes, not your sleeping eyes, but your waking curiosity, you can find it. In the shimmer of high-energy collisions. In the heartbeat of distant galaxies. In the way light moves when particles meet and disappear. This is not the stuff of dreams. It is the stuff of science. Tonight, you begin a journey through this mirrored realm, a quiet voyage across the divide between what is and what might have been. Along the way, you'll meet the tiny actors of this cosmic play, positrons that wink into being only to vanish again, particles that hum with potential, engines that might one day ride annihilation like wind. But for now, it begins in stillness. You rest beneath a sky that once held balance, matter and antimatter in perfect tension. Imagine a universe where every particle had its partner, every heartbeat its counterbeat. There's a kind of poetry in that symmetry, isn't there? A symmetry that almost survived. You feel it now in your own breath, the inhale and the exhale, opposites working together. Matter and antimatter are like that too, not enemies, but complements. Each one needed to complete the other, to tell the full story of how everything began. What happened to the antimatter? That question whispers through time. Scientists, curious and patient, have chased that whisper. They build great machines to peer into the deep fabric of existence, to catch fleeting glimpses of antimatter's glow. They don't always find answers, but they do find beauty in the process, in the patience, in the act of wondering. And you, lying here in the quiet hours of night, are part of that wondering. Your body is made entirely of matter. Every atom in you once pushed its way out of the early fire of the universe, defying the odds. That you exist at all is proof that something tipped the balance. But where did the rest go? Why did the mirror break? The stars don't answer, but they invite you to keep asking. And so, gently, you do. As the sky deepens to velvet and the first pinpricks of starlight appear, you drift further into that question. What if the mirror particles still exist, hiding in plain sight? What if they flicker into being in places we've barely begun to look? What if their story is not finished? The night stretches wide, a cradle for thoughts too big for the day. In the chapters ahead, you'll walk beside particles born from starlight. You'll touch the edges of what can't be held and feel the silent hum of symmetry waiting to return. But next, you will meet a particular particle, not just antimatter in the abstract, but one small, elegant twin. A mirror of the electron, born of cosmic fire, gone in an instant, but not forgotten. The story continues not in galaxies, but in a single flicker, a brief, brilliant breath of energy. Imagine an electron, a tiny, restless particle that orbits the heart of every atom in your body. It hums with motion, carries a negative charge, like a breeze drawn inward. You can't see it, but without it, your world would unravel. Electrons make bonds, build shapes, carry the current of thought through your brain. Now, imagine its reflection. Positron. It is the same, and yet not. Where the electron pulls, the positron pushes. Where the electron dances with atoms, the positron passes like a ghost. It is its perfect opposite, a mirror so precise, so fragile, that when they meet, they vanish together in a flash of light. Not destruction, but release, as if the tension between them resolves, like a note completing a chord. The positron is not just a thought experiment. It's real. High above you, in the upper reaches of the atmosphere, the sky is constantly being brushed by particles from space, cosmic rays. When these rays strike atoms in the air, they create showers of subatomic fragments. For just the briefest moment, in that chaos of motion, positrons are born. Tiny flashes, twins without time. They don't last long. Here on Earth, they have no place to belong. They drift, searching for something to cling to, and when they find an electron, as they inevitably do, they embrace and disappear, leaving behind two soft bursts of light, like the exhale of a dream. You are surrounded by these stories, even if you don't see them. In fact, every time a medical PET scan is done, a positron emission tomography scan, a person is bathed briefly and carefully in positrons. These particles travel only a short distance in the body before finding electrons. When they meet, they vanish, and in doing so, they send out tiny messengers of light. That light tells doctors a story, of shape, of function, of healing. Isn't it beautiful? That something so brief, so fleeting, can be used to see what's hidden inside you. The positron was the first antimatter particle ever discovered. Not predicted by accident, but by mathematics, a solution to an equation that shouldn't have been there, but was. A young physicist named Paul Dirac saw it like a ripple in a reflection, and he trusted the math enough to believe in what had never been seen. Years later, in the bright sunlight of 1932, a detector caught something strange. A particle behaving like an electron, but curving the wrong way in a magnetic field. A mirror particle. The positron had arrived. In this moment, science changed. The universe suddenly had two sides, and the idea that antimatter might not only exist but be made, studied, perhaps even used, began to bloom. You imagine holding one now, a positron, resting like a firefly in your palm. It wouldn't stay long. It would find the nearest electron, perhaps in your hand, perhaps in the air, and disappear with it. Gone in less than a blink, but leaving behind something more than light. It leaves a question, promise, a quiet kind of magic. There are other mirror particles, too. Each particle you've heard of has its antimatter counterpart, the antiproton, the antineutron, the antimuon. But the positron is the gentlest, the most graceful. The one that begins the story softly. You think about balance. How strange and how perfect that the world might have once contained equal parts of matter and antimatter. Every electron, every proton, every neutron balanced by its reverse. And yet, that world is not the one we live in. Where did all the positrons go? That puzzle hums beneath the surface of science. It's as if someone once set a long table for two, matter and antimatter, but only one guest stayed for dinner. The other vanished before the meal began. Even now, scientists search for hints that pockets of antimatter might remain. That somewhere, out past the veil of the observable universe, a galaxy might spin, not made of matter, but its reflection. A shadow galaxy, calm and complete, just out of reach. But the evidence remains faint. The positrons that reach us from space are travelers, not residents. No antimatter worlds have yet been found. Still, we can make them momentarily here on Earth. In the dance of particles in accelerators, in the collisions of high-energy, positrons are created. Caught, studied, sometimes even stored. Not in cages, but in traps made of fields and vacuum. A breath held in a bottle of silence. And it all begins with this particle. This tiny, glimmering twin. You feel a kind of tenderness for it. Not just because it's rare or because it flickers so briefly, but because it opens a door. A door into the mirrored side of the cosmos, where light is born not from fire, but from the quiet reunion of opposites. The positron doesn't rage. It doesn't burn. It simply appears, waits, and then vanishes in light. And that light, however soft, marks the boundary between what is and what might have been. You rest with that thought now. The idea that something so small could carry the weight of a whole hidden universe. That within every blink of energy, there is the shadow of balance. A world just slightly turned, glowing at the edge of vision, and in the space between its creation and its vanishing, a question. Where do such particles come from when there is nothing there? How can the vacuum, empty space, give birth to something so real? In the next chapter, you will step into that vacuum and listen for the sparks. You breathe in the silence, thinking of nothing. But even in nothing, in true stillness, something stirs. You are floating now gently in a space with no stars. Not the quiet of night, but the quiet before anything begins. This is the vacuum, the so-called emptiness between all things. Cold, vast, weightless. You might imagine it as a perfect stillness, an absence of motion, of matter, of meaning. But that idea is an illusion. The vacuum is not empty at all. Beneath its still surface, it quivers with hidden motion like a pond, glassy at first glance, but alive with minnows just below. These are quantum fluctuations born not from matter, but from the rules that govern reality itself. Rules that say, energy cannot stay perfectly still. Even space, even silence is restless. You cannot touch these flickers, cannot catch them in your hand. They vanish before they can be seen, living shorter than the blink of a thought. And yet their traces are everywhere. They shape the world you live in. They ripple through the fabric of existence. Among these flickers, something remarkable happens. Pairs of particles pop into being, a matter particle and its antimatter twin. They are called virtual particles because they are not quite real, not quite stable. They exist in the space between certainty and chance. A positron, an electron, born together, vanishing together. Like dancers who step onto the stage, spin once, and disappear before the curtain lifts. They are like sparks in the dark, not bright, but constant. You float through the sea now, and though it looks still, your senses begin to tune in. Tiny pops. Little pairings. Creation balanced by annihilation. No light, no heat, just the quiet hum of reality stretching and settling again and again. In physics, this is called the quantum vacuum, a place where uncertainty gives birth to possibility. If a strong enough force is applied, an electric field, for example, of unimaginable strength, those virtual particles can be pulled apart. They can be made real. Caught before they vanish. It's like catching a snowflake before it melts. Hold it long enough and it becomes part of the world. This isn't fantasy. It has been done. In massive particle accelerators, where energy is packed into tiny points, new particles appear. Matter and antimatter, summoned from the empty air, it seems, but truly coaxed from the ever-bubbling vacuum. Isn't it strange? That emptiness can create? That what we once thought of as nothing is actually woven from fleeting somethings. This is how the universe behaves on the smallest scales, unpredictably, softly, beautifully. And within that vacuum, antimatter is always there. Always ready to flicker. It makes you wonder how solid anything is, really. Your hand, your bed, the breath you take, they all seem so stable. But beneath them is this sea of flickers. Beneath every stillness is motion. Beneath every silence, a song. Some scientists believe that this vacuum energy, though tiny and hidden, adds up. That it might even shape the destiny of the universe, causing it to stretch, to expand, to move apart forever. Others see in it a clue to the birth of all things, as if the Big Bang was itself a fluctuation, a sudden wild breath in a sea of potential. You don't need to decide. You only need to feel the wonder. You lie there, wrapped in stillness, knowing now that the stillness is full. That the very space between your thoughts hums with invisible life. It makes the universe feel alive, not because it is loud, but because even its silence pulses. And somewhere, in that pulse, antimatter waits. It is not gone, only hidden. Not lost, only folded into the flickering fabric of what seems to be empty. And though we can't hold it long, we can see its shadow. We can listen for its whisper. We can learn from its pattern. The vacuum is not absence. It is possibility. And what is sleep if not the same? A kind of vacuum of the day, an open space where thoughts come and go, where images arise and dissolve. In your dreams, too, particles appear and vanish. You do not grasp them. You simply feel them pass. You drift deeper now, floating through this quantum sea. You wonder, if particles can be born from nothing, could we ever catch one? Could we trap something so fleeting, so wild? Could we keep a piece of antimatter still, if only for a moment? To answer that, you must visit the place where sparks become substance. Where scientists wait in silence to catch a star. You drift now from the vastness of space to something smaller, a quiet laboratory on Earth. It's not large. It does not sparkle. It doesn't hum with drama or flicker with science fiction light. From the outside, it looks plain, even dull. But deep within its walls, something extraordinary unfolds. In this lab, the invisible is invited to stay a while. You step softly into a chamber where the air has been removed, not just a little, but nearly all of it. A near-perfect vacuum. Within this space, inside a delicate web of magnetic fields and cooled machinery, scientists have built a kind of cradle. Not for a baby, but for a particle made of mystery. An atom of antimatter. This is not a story from the distant past. It is happening now. And you are there in the quiet moment before the experiment begins. The lights are dimmed not because they must be, but because everyone here moves gently, respectfully. Antimatter is not dangerous in and of itself. But it is fragile not in its structure, but in its relationship with the world. The moment it touches matter, it vanishes in a burst of energy. The two cannot coexist without consequence. So the challenge is not making antimatter. We've done that many times. The challenge is keeping it, catching it, holding it in a place where it touches nothing. And here, on this day, a few atoms of antihydrogen, the antimatter mirror of the simplest element, are trapped. Hydrogen, in your world, is a proton and an electron. A tiny sun with a circling planet. Antihydrogen is the opposite, an antiproton and a positron. Still spinning, still balanced, but reversed. A reflection. The lab doesn't look like it holds a star. But in its vacuum, in its stillness, these few atoms glow with potential. They are cold, colder than space, chilled to a whisper above absolute zero, because in the slowing of motion comes the chance for stillness. Stillness is survival. And for a few minutes, or sometimes longer, they stay. You might imagine them as snowflakes hovering in the air, caught not by a hand but by invisible threads of magnetism. No touch, no jar, only fields carefully shaped, precisely tuned like hands made of wind. These fields keep the antimatter atoms from brushing against the walls, from brushing against the world. This is the miracle. To take something that disappears on contact and let it exist. To build not a container, but a silence where a particle can rest. You watch in this imagined moment as the detectors confirm what eyes cannot see. The atoms are there. Real. Mirrored. Waiting. Not vanishing, not yet. They have been caught, not for a story, but for science. What can we learn from them? In these labs, researchers ask, does antimatter fall? Does gravity pull it the same way it pulls you? This is not a small question. It is one of the great open thoughts in physics. If antimatter falls differently, even a little, it could mean that the universe plays by stranger rules than we imagined. The atoms in this lab do not answer quickly. They are silent. They drift. They are nudged and measured delicately like reading poetry written in candle smoke. And yet in their silence they teach. Each second they linger is a triumph. Each moment they do not touch, do not vanish, is data. Slowly, these mirror atoms are revealing whether they are truly identical to matter or if, somewhere, in the folds of the symmetry, a difference lies hidden. You might wonder how something so small can carry so much meaning. But this is how science moves, not always in leaps, but in the patient holding of a question. In creating a space where the question does not collapse. In this case, quite literally in creating a space where the antimatter does not collide. You feel a stillness now that matches the lab. A sense that even here, in this imagined room of cold metal and warm minds, something sacred is unfolding. A glimpse into a part of the universe that mostly slipped away. This is what it means to catch a star. Not to hold fire, but to give it room to glow. Not to capture light, but to stop it just long enough to understand how it shines. Outside the lab, the world spins on. But inside, a few atoms of antihydrogen hover in perfect silence between touch and untouched, between known and unknown. They will not last. The fields will shift. The particles will meet their mirrored halves and disappear in light. But for now they stay. And in that staying, a door remains open. You might not know the answers. The scientists might not either. But by creating a space for antimatter to simply exist, even briefly, we invite the universe to speak back. We ask it, what else have you hidden in the folds? And from that quiet glow, the next question begins to form. If this is the light born from annihilation, what happens when matter and antimatter finally touch? It begins not with a bang, but with a breath. In the deepest quiet, deeper than sleep, deeper than words, something small and hidden begins to vanish. Not in fear, not in pain, but in peace. An electron and its twin, a positron, find each other in the silence. They do not wrestle. They do not rage. They simply meet and disappear, but not into nothing. In their place comes light, soft, precise, unmistakable. Two photons, particles of light, born in perfect balance. A transformation so complete, so elegant, that nothing of their mass remains. Only energy set free. You lie still, listening to the idea that two things, opposite but equal, can touch and become something new. Not war, not chaos, but release. This is what happens when matter and antimatter meet. Annihilation, the physicists call it, but that word sounds harsher than what truly unfolds. It is not a breaking, it is a surrender, a giving back to the universe of the energy that held them in form, a return. In this moment, the boundaries between substance and light blur. Mass becomes energy, shape becomes motion. The very fabric of reality stretches a little as these pairs wink out and something else winks in. You have felt this even without knowing. The warmth of sunlight on your skin. Some of that light was once born in a process not so different. In the core of a star, particles meet, transform, vanish, and in doing so shine. Fusion gives way to fire. Annihilation gives way to radiance. And yet, the light you feel is older than memory. It has traveled through time and silence to reach you. Here on Earth, we have learned to create the conditions where this meeting happens. Not always softly, in laboratories, in accelerators, in bursts of energy too fast for the eye, but the principle is always the same. Matter meets antimatter. They cancel, and the cancellation is not emptiness, but brilliance. The energy released from just one meeting of an electron and a positron is tiny. A single spark, too small to warm a hand. But scaled up, multiplied by trillions, the energy becomes immense. Theoretically, this process is the most efficient release of energy possible. 100% of the mass becomes energy. No ash, no residue, no smoke, just light. Imagine that. You carry it with you, this potential. Every atom in your body, every part of your being holds a kind of quiet tension. A stored echo of the moment when mass could, if invited, become motion. Now imagine capturing that moment. Not just seeing it, but using it. This is where the dream of antimatter engines begins. A ship powered not by burning fuel, but by touching opposites. By inviting matter and antimatter to meet. Slowly, carefully, rhythmically, and capturing the light that results. No gears, no combustion, no pollution, only radiance harnessed for movement. Of course, the dream is not yet real. The antimatter we make is far too little, too hard to store, too precious to waste. But the principle is sound. The physics is clear. The spark is waiting. And so we wonder, could a spacecraft, one day, be driven by this soft fire? By controlled annihilations, guiding a vessel through the dark, leaving only light behind? It is not fantasy. It is physics waiting for engineering to catch up. You see the image in your mind now. A quiet ship, silver and still, gliding not on wind or flame, but on the dance of disappearing twins. A ship moved not by push, but by transformation. By letting go. Even here, in your room, wrapped in stillness, you feel the elegance of it. That the future might ride on something so poetic, so symmetrical, so complete. But there is another kind of beauty in this process, not just in motion, but in meaning. Annihilation is not a loss. It is not the end of the particles. It is a conversion, a rewriting of identity. The energy was always there, folded into mass like light inside a seed. And now, released, it becomes something freer, something simpler. You can think of it as a kind of alchemy, not the old kind of gold and lead, but a truer transformation. Mass to light, structure to shimmer. In every annihilation, the universe briefly reminds itself of what it's made from. And when you watch it, in a diagram or in your imagination, you see not violence, but peace. Two particles, equal and opposite, returning their borrowed energy to the cosmos. And yet, for all its elegance, the process is difficult to harness. Antimatter doesn't linger. You must trap it, hold it, guide it. You must coax it gently to meet its partner, in the right place at the right time. Like lighting a candle in a breeze, possible but requiring care. That care, that precision, is the next step in the journey. Because if this fire can be tamed, if we can build the right cradle, the right field, the right rhythm, then we can turn this transformation into propulsion. We can take the light born from vanishing particles and use it to move. Imagine a rocket with no flame, only shimmer. Imagine space itself bending just slightly as it rides the wake of pure energy. Imagine going farther, faster, not by force but by elegance. You lie back and let the image settle. A future where we glide across the stars, not with explosions, but with soft annihilations. Not with noise, but with balance. A voyage powered by opposites meeting in peace. Sounds like a dream, but it begins here, in this soft fire, in this quiet light, in this perfect vanishing. And so the next question blooms, gentle as a ripple. Could we build such a ship? Could we truly ride the wind of disappearing matter? Could we sail on the annihilation itself and go where stars are born? You drift now through a new kind of silence, one not of stillness, but of suspended motion. Imagine yourself aboard a vessel unlike any that has yet crossed the dark. There are no wings here, no smoke trails, no roar. It glides not by pushing against air or spinning wheels, but by something subtler, a shimmer, a hush, a release. You are riding on annihilation. Not chaos, not explosion, but balance transformed into motion. The ship beneath you, if you can call it a ship, is less a machine and more a conversation with physics. Its structure is sleek, tuned like an instrument to the precise harmonies of energy and mass. There are no gears to grind, no engines to ignite. There is only the soft, deliberate meeting of particles and their perfect twins. Antimatter meets matter. They vanish. And from that vanishing, a pulse. A photon or many rushes away, perfectly aimed. The ship moves in the opposite direction, guided by the ancient law of momentum. Action and reaction. A light goes forward and you move back. Over and over. Not in jolts, but in waves. Gentle. Steady. Sure. This is the dream of antimatter propulsion. It is not fantasy. It is not beyond physics. The energy released from matter-antimatter annihilation is real, powerful, efficient, pure. More than any combustion engine could ever offer. More than nuclear fission or fusion. 100% of mass becomes usable energy. Imagine that. A teaspoon of antimatter could, in theory, carry you farther than a mountain of rocket fuel. But the dream is not just about energy. It's about elegance. You picture a small chamber at the heart of the ship, shielded, magnetized, glowing faintly with the faintest particles of antimatter. Each one cradled in vacuum, held in place by invisible threads of force. Nearby, tiny jets of normal matter wait. And when the time comes, they meet. Not all at once, not in a blast, but in a rhythm. A beat. A tempo tuned to the needs of motion. Each annihilation produces photons or particles or fields depending on design. That energy is captured, shaped, and pushed through nozzles or field structures, forming thrust. There is no smoke, no fuel tanks draining, no ash, only light released in purpose. The ship is propelled not by what it carries, but by what it becomes. You feel it now, the glide. Not acceleration as we know it, not a shove, but a tide. Over days, then weeks, the speed builds. With each gentle annihilation, the ship moves faster. There is no friction in space to resist you. Just emptiness, vast and yielding. The speed grows, not with struggle, but with patience. This kind of travel requires letting go of urgency. You do not leap to the stars. You sail to them. Each particle pairing becomes a stroke of the oar. Each flash of light a new reach into distance. And over time, what was slow becomes swift. What was motionless becomes unstoppable. Even now, scientists have sketched such engines. Theoretical designs line chalkboards and journals, some that use direct photon propulsion, others that channel charged particles from annihilation into magnetic nozzles. Complex, yes, but not impossible. The hurdles are real. Antimatter is difficult to produce, expensive to store, delicate to handle. A single atom, if it touches the wrong surface, is gone. But in the minds of dreamers and engineers, these challenges are blueprints, not brick walls. You imagine Earth shrinking behind the ship. A pale sphere, receding into memory as you drift past Mars, past Jupiter, beyond the orbit of Pluto. You are not chasing the stars. You are moving with them. Held not by gravity, but by intention. By a gentle stream of released potential. You begin to see space differently now. Not as a void to be crossed, but as an ocean of quiet, and you riding its invisible wind. Even the concept of time changes. There are no clocks aboard this kind of ship, only the beat of the propulsion, the rhythm of the releases. You measure distance not in kilometers, but in conversions, in the number of annihilations that have pushed you forward. Each one a tiny surrender. A letting go of particles into the freedom of light. It feels almost spiritual, doesn't it? To move through the universe not by force, but by trust, trusting that the laws of nature are enough. That opposites meeting in peace can carry you farther than fire ever could. And what might we find out there? Planets unseen. Orbits unbroken for eons. Light that left its star before our species took its first breath. All reachable if we learn to move in this way. You lie back in your imagined vessel. There is no vibration. No noise. Only the faint ticking of the control systems, the pulse of fields adjusting, and a soft internal warmth that tells you the annihilations are happening. Gently. Purposefully. Behind each hum, a pair of particles, once apart, now whole, and then gone. And yet nothing is lost. Only changed. That is the true lesson of the annihilation wind, that even what disappears can give birth to movement, that even what ends can leave behind direction. You let that lesson settle into you. You are floating now not just in space, but in thought. Not asking where to go, but how to shape the silence that takes you there. And yet, even as you drift deeper into this dream of motion, the question remains. What price must we pay to make this possible? What effort, what scale, what energy does it take to make antimatter real at all? You awaken now inside a cathedral of steel and silence. Not a temple of faith, but of science. A place buried deep beneath the earth where circles of magnets stretch for miles, bending particles into spirals of light. These are the machines that touch the edge of the invisible. Here, antimatter is not found. It is made, and it is never easy. You walk slowly through the corridor, humming with cool air and distant vibrations. Overhead, the walls curve like ribs wrapped in cables and promise. This is a particle accelerator, a ring of precision and possibility. A place where protons race, guided by magnets nearly to the speed of light. Not to collide in chaos, but to create. To coax reality into giving up its secrets and sometimes its opposites. Here, in moments shorter than any blink, matter and energy twist together. The collisions produce not one thing, but many, a bouquet of particles blooming from impact. Among them, rarely, a twin pair, a particle and its mirror. Matter and antimatter. You may not see it happen, but in the data it sings. A positron, an antiproton, traced not by eye, but by pattern curved paths in a magnetic field curled like the spiral of a shell. Each one a ghost made visible for an instant, and then gone unless caught. To make just one of these particles requires immense energy. Megawatts of power, kilometers of machinery, precision down to fractions of a millimeter. The beam must be focused, sharpened like a needle of starlight. And even then, the yield is tiny. A billion collisions. A few precious specks of antimatter. If energy were sand, this would be the gold dust hidden in the grains. It humbles you, standing in this vastness, knowing what it takes to make a single antiproton. Entire teams working for years. Supercooled magnets. Vacuum chambers emptier than space. Systems tuned so finely they can sense a wobble in a proton's path. And why do we do it? Not to power cities. Not yet. But to understand. To ask the universe, why did matter survive? Why is there something instead of nothing? Could the laws that shape the stars be used to shape our journeys? The antimatter made here is not stored in jars or scooped into canisters. It is trapped, suspended in fields, kept far from every wall. It's like holding a firefly on a thread of air. Even so, it exists. And existence is the first miracle. At facilities like CERN and Fermilab, we have not just made antimatter, we have studied it. Compared it to its sibling. Measured its mass, its charge, its spin. And so far, it behaves exactly like matter, but reversed. The same and yet not the same. You lean in, feeling the weight of that paradox. For all its cost, its delicacy, its danger, antimatter is not strange. It is symmetry. It is balance returned. And balance is never free. To make enough antimatter to power a spacecraft would require vast new infrastructure. Accelerators larger than any we've built. Power systems that draw from stars. Entire economies of energy focused on creating just a few atoms of mirror light. It seems impossible. But so did flight. So did orbit. So did every first spark of an idea. You remember, once people thought steam could never lift iron. That fire could never leave Earth. That silence could never be breached by signal. And now here you stand in a corridor where particles vanish and reappear, where time bends in loops and opposites are born in flashes. Progress, like antimatter, is born from collisions. We do not walk gently into new frontiers. We build them slowly from effort. And so the cost, immense as it may be, is not discouragement. It is invitation. Every obstacle reveals the edge of possibility. You place your hand lightly on the railing. The floor hums with unseen motion. Beneath you, magnets thrum. Particles spin. Somewhere, in this vast ring of silence, two beams approach. They will meet. They will bloom. And from that collision, something unlike anything may emerge. That is how it always begins. From energy, a particle. From the particle, a question. From the question, a ship. You close your eyes. The scale of it washes over you, not as fear, but as awe. The universe is patient, and so must we be. To catch a single particle, we build machines the size of cities. To hold its twin, we learn the art of silence. This is the cost, and it is also the promise. We are learning how to make fuel not from forests or fossils, but from the very structure of reality. We are learning how to touch the mirror gently, respectfully, and ask it to light our way. But even if we make the antimatter, how do we hold it? How do we stir something that disappears on touch? That next step requires a bottle with no walls. There is a stillness now, like the moment just before snow begins to fall. You have seen the power of antimatter. You felt the energy, the radiance released in its vanishing. But what good is a star you cannot hold? What use is a flame that disappears the instant it brushes the world? To harness this mirror of matter, we must first learn how to keep it from touching anything at all. You close your eyes and imagine a jar. Simple, glass, familiar. Inside, a flicker of light, a firefly, maybe. Glowing. Alive. The child in you wants to screw on the lid and carry the light home. But antimatter cannot live in a jar. Even the thinnest glass, the gentlest surface, is made of matter. And to an antiparticle, touching any part of the jar is a death sentence. The moment it collides with air, with wall, with the smallest speck of dust, it disappears. And with it, the hope of motion, the light, the energy. Gone. So we build something else. We build a bottle without walls. In laboratories across the world, scientists have learned how to suspend antimatter in nothing held not by hands, but by fields. Magnetic and electric forces form a shape, a space, an invisible cradle in which particles can rest. The result is not visible. You cannot see the trap. But inside, positrons and antiprotons hover like stars caught between thought and gravity. They spin in circles confined by careful mathematics, guided by silence. These devices are called penning traps, and they are like harp strings for the invisible. Charged plates and precise magnetic fields combine to sculpt a void where antimatter drifts, untouched. If the field falters even slightly, the particle is lost. It's like catching rain on a spiderweb. This is not brute force science. This is art. The patience it takes to hold a single antiparticle is immense. Cooling systems chill the trap to near absolute zero, not just to slow the particles, but to calm the background noise. Every vibration, every stray field must be hushed. You walk now in your mind through one of these chambers. It is smaller than you imagined. Not a room, but a chamber the size of your hand. Tubes and wires reach toward it like branches cradling a bird's nest. And inside that nest, silence. A particle waits. It is strange to think of containment not as force, but as balance. Not locking something away, but shaping the space around it so that it chooses, in a way, to stay. There is something deeply human about it. We have always tried to hold light. With fire. With candles. With glass bulbs and glowing screens. But antimatter light is different. You cannot cage it. You must listen to it, design for it, offer it a place so finely tuned that it has no need to flee. You breathe slowly, letting that idea settle in. That to store the most powerful fuel we've ever imagined, we must become more delicate, more precise, more respectful. The louder we grasp, the quicker it vanishes. And yet, even with these traps, the antimatter we store today is measured in atoms, not ounces. We have caught a few hundred antiprotons, a few thousand positrons, enough to study, to understand, but not yet enough to travel. Scaling this up, storing grams, kilograms, would require advances in trapping fields, energy containment, shielding, and safety. But the principles remain the same. You must never let it touch. Imagine a spacecraft with chambers lined not with steel, but with layered field traps. Each antimatter particle held like a note in a frozen chord, suspended until its moment comes. Released one at a time, or in chorus, to drive the engine forward. The antimatter does not explode. It completes a cycle. It meets its twin and disappears, but in doing so, it moves you. You might never see it, but you would feel the effect, the motion, the change, and you would know this moment of silence, of careful holding made everything possible. There's a kind of metaphor in it, isn't there? That some things in life, like antimatter, cannot be gripped tightly. That the most powerful forces are those we must hold with care, gently, precisely, without pressure. Energy, love, wonder, all things that slip away if forced too hard. You lie back again, your thoughts slowed to match the rhythm of this holding. Around you, there is nothing loud. Only containment. Only balance. And the thought that inside these invisible cradles, the fuel of the future already waits, flickering, patient, ready to shine. But containment alone is not enough. To go farther, truly farther, we must do more than hold. We must imagine. What kind of engine could ride such a delicate, powerful source? What kind of ship could be built around silence and light? You drift now toward that question. Into the sketches of scientists, the notebooks of dreamers, and into the engines of tomorrow. You walk now through a space filled with sketches. Not paintings, not blueprints quite, but quiet diagrams, scribbled lines across notepads and glowing screens, engine rings, containment shells, magnetic nozzles shaped like petals or wings. These are not fantasies. They are futures drawn gently in pencil and math. This is where science becomes story, where engineers sit in silence imagining motion, imagining what has never flown. You picture them. A desk lamp glowing softly over a coffee-ringed notebook, a mind wandering through equations, eyes closed, dreaming of how antimatter might become not just a particle caught in a trap, but the heart of a ship, an antimatter engine. It begins not with fire, but with containment. First, the antimatter must be held, as you've seen, in a kind of magnetic cradle, safe, untouched. Then, at the moment of need, it is released into a chamber where its counterpart, a carefully metered bit of matter, is waiting. When the two meet, they vanish. But their vanishing is not an end. It is the engine's breath. The energy from that annihilation is channeled, shaped by electromagnetic fields, focused into thrust. No pistons, no smoke, no noise. Just a pulse of light, a push. One atom, then another. One rhythm, then another. Like notes in a song. You begin to see the engine not as machinery, but as choreography. A quiet dance of particles, meeting and disappearing in perfect time. There are many versions drawn on these desks. One engine uses neutral pions, short-lived particles created in annihilation, to produce thrust directly, like a laser pulse against the dark. Another converts the energy into heat, drives ionized gas through a nozzle, sculpting motion from temperature. Others still imagine pure photon engines. No fuel expelled, just light directed backward, and the ship gliding forward, gently, endlessly. Some designs are small, like the heart of a hummingbird. Others are vast, engines the size of cities, meant to carry thousands across stars. But all of them share one thing. They do not move by burning. They move by balance. This is what makes antimatter engines so quietly radical. They are not louder than rockets. They are quieter. Not less powerful, but more precise, more elegant. Where traditional engines are built on pressure, combustion, exhaust, these future machines are built on transformation. They ask a question, softly. What if movement didn't come from force, but from surrender? What if going forward came from letting go? You drift through these designs, each one speaking a different dialect of the same dream. A dream that someday we will move not just within our solar system, but beyond. Beyond Mars, beyond the Kuiper Belt, beyond the dim glow of the sun's last reach, toward stars we now only see as dots. There is a term whispered in these circles, relativistic speeds. It means fast enough that time itself begins to bend. Fast enough that, in theory, we could cross light years in a single lifetime. If we can perfect antimatter propulsion, that dream edges closer. You pause now in your drifting to consider what that means. A ship launched not for war, not for conquest, but for understanding. A vessel humming on the soft wind of annihilation. Its systems quiet, its destination uncertain. No flags, no noise, only a crew listening to the stars. What would it be like to stand aboard such a craft? To look out a narrow window and see not clouds, not blue, but the wide velvet of interstellar space? To feel no vibration beneath your feet, only the steady drift of purpose? You would not feel movement, only change. Not a rush, but a journey unfolding like breath. And inside the engine room, somewhere beneath your feet or far at the rear, particles would be meeting their twins. Quietly, releasing light, making motion. Not all journeys are loud. Some are born from silence, carried by science, and guided by questions. And yet, these designs are still on paper. These ships are still dreams. There are problems to solve. So many. Where will the antimatter come from? How will we store enough to power a full journey? How will we protect the ship from the particles created in Annihilation? Some of them dangerous, fleeting, hot with energy. There are solutions being drawn, softly, in quiet corners of labs and mines. Multi-layered shielding, self-regulating magnetic fields, algorithms to adjust particle flow in real time. Step by step, sketch by sketch, we get closer. You look down at a model, just a wireframe, glowing on a screen. It is long and narrow, a central spine, curved containment rings, a propulsion chamber at the back, and a quiet habitat nestled at the front, shielded in soft geometry. It doesn't look like a rocket. It looks like a song. And maybe that's what all this is. Not just science, not just engineering, but melody, a harmony of opposites, matter and antimatter, silence and motion, effort and letting go. You leave the dreaming room now, your breath slow, your mind full. You carry with you the sketches, the notes, the deep understanding that behind every particle of progress, there is a person imagining. Sketching on napkins, building small, trying again. The future begins this way, not with arrival, but with design. But even as we build these engines, draw them, dream them, dare to test them, the question lingers, why is there so little antimatter in the universe? Why did one side of the mirror remain, while the other nearly vanished? You drift into that question now, into the memory of the beginning, into the place where the universe made a choice, or perhaps simply remembered something we still don't understand. You lie back now, deeper into stillness than before. All around you, the soft hum of stars unseen, distant galaxies turning like lanterns in the dark. You are no longer walking through laboratories or engines. You are drifting through a question old as time, quiet as breath. If matter and antimatter were born together, why did one stay? And why did the other fade? The Big Bang, we are told, birthed both in equal parts, mirror twins, born of the same fire. For every proton, an antiproton. For every electron, a positron. Equal, opposite, perfectly matched. But that is not the world you live in. You feel it in your own body, your atoms, your breath, your cells, all made of matter. Not one speck of antimatter remains in the fabric of you. Not in the stones of the earth, not in the light of the moon, not in the winds of Jupiter. The mirror is gone. Somewhere, early on, something tipped the balance. No one knows quite how. Some theories say that particles and antiparticles decay in slightly different ways, that their symmetry, while beautiful, is imperfect. A flaw so small and subtle it would take 1,000 galaxies of data to detect it. Others wonder if, in that brief moment after creation, the universe blinked, chose, in some quantum way, to favor one side of itself. A coin toss, once made, set forever in motion. Or maybe it wasn't choice or flaw. Maybe it was memory. Maybe the universe, in its first breath, remembered something. A pattern. A leaning. A soft turning toward matter, like a river remembering which way it bends. You float in this thought. Because if matter had not one, if the two had canceled perfectly, there would be nothing. No stars. No planets. No trees. No stories. No ships. No you. Just light. Endless, perfect light and emptiness. And so the imbalance, small as it may have been, was everything. It made the dust that formed suns. The atoms that formed oceans. The molecules that became dreams. The great irony, the universe is built on asymmetry. Perfection would have erased it all. You imagine now what it means to be here, wrapped in matter, in a universe that almost wasn't. Your very existence is a kind of leftover. A sliver of imbalance. A whisper of particles that escape their mirrored fate. A cosmic survival. And yet even now the mirror haunts the edges. In particle accelerators, in cosmic rays, in the deep silence between galaxies, antimatter still flickers into being. Short-lived. Fragile. But real. As if the universe remembers. As if it cannot quite forget the twin it once embraced. This memory, not of particles, but of possibility, guides scientists still. They search the skies for signs of anti-galaxies, for flickers of unexpected gamma rays that might mark the meeting of matter and antimatter far away. Nothing certain has been found. Not yet. But the search continues. Not because the answer is needed, but because the question is beautiful. You breathe in that beauty now. You do not need to understand every equation to feel its poetry. You do not need to memorize the names of particles to feel the wonder of their dance. You only need to lie here, quiet and curious, and let the mystery settle around you like a blanket. The universe is vast, older than memory, younger than thought. It speaks not in answers, but in invitations. To look, to wonder, to follow a positron into silence. And when you close your eyes tonight, you carry the shape of that silence. A journey that began in particles and ends in possibility. You remember the fire from nothing, the engines of light, the traps that hold without touching, the ships that sail not with noise, but with grace. And above all, you remember that you are made of what remained. A child of imbalance, a spark that outlasted annihilation. The stars that guide you are not alone in their brightness. You too are light, slowed into form. You drift now into dreams, your breath soft, your body weightless, held in the cradle of thought. And just before sleep takes you, a final question whispers itself forward. If antimatter was almost forgotten, what else might the universe remember? When we are finally ready to ask,